going to journey back in time a little bit. This is more of a traditional storage technology than the previous talk, which was about lake houses, data lake houses. NFS has been part of the storage world since the mid-'80s. It's a very venerable technology. A lot of people understand it and deploy it. My responsibility is to act as a steward of the code base that's in the Linux kernel that implements an NFS server. NFS being a client-server protocol in the classic sense of that term. I just want to put this slide up to point out that yes, I do work for Oracle, but no, I'm not going to talk about Oracle products today. You can ask questions, and what I might know about them, I can probably share because I don't know a lot about them, but I'm an upstream Linux guy, so that's what I'm going to talk about. So I sort of broke down the talk into four pieces, these four pieces. I may or may not stick to this, and depending on whatever questions or other interaction you might want to have with me, we can take this in any direction you want. Although I do reserve the right to tell you to come talk to me afterwards in order to keep this on schedule. So some of you may be familiar with the NFS server in Linux. It's changed significantly in the last 2 years or so, or maybe 3. And in fact, I don't think I've ever given a talk like this at this event. So reintroducing may mean for you, or it may mean for me, who knows. I've been the co-maintainer of the NFS server in Linux for the last 3 or 4 years, I guess around the time of COVID. Yeah, I guess 2020, 21. I joined when Bruce Fields was a maintainer, and now he's in semi-retirement. He's playing in a rock band, believe it or not. That's a true story. And now my co-maintainer is Jeff Layton, who's got a very broad array of experience in Linux file systems. He's worked on the VFS and in Ceph and in other places, as well as been being in and out of the NFS community for the last 10 or 15 years. He's got quite a lot of experience. I'm also very ably aided by a team of reviewers. I very much appreciate review and contributions. This code base would not be what it is today without the contributions and expertise of those folks. So what does this thing do? We support all versions of NFS today, from version 2, from, as I said, the 1980s, all the way up to 4.2 and newer extensions. The 4.2 features that might interest you are Read Plus, which is a mechanism that NFS added recently to do sparse reading, so you can get a read result back that says the range you asked for is not allocated on disk, so just fill it in with zeros, and it doesn't have to send all that data over the network. It just says it sends a little packet that says it's all zeros. Or it can get more complicated than that, of course, but in our implementation, we only send either data or zeros, data or a whole. Allocate, which is kind of the opposite. It's basically a write same for you SCSI folks. Copy offload, that's also something SCSI has, where you can point the server at a couple of files and say, move this range of bytes in that file to this range in this other file. The two files can be on different servers. So that's kind of an interesting technology, and it has a lot of evolving to do. I'll talk a little bit more in more detail in a few slides. This thing called security labels. Basically, this is SE Linux, more or less standardized and put into NFS. We support that. I think we're one of the only server implementations that supports it. Some of the extensions I mentioned, the newer than NFS v4.2 extensions, the big one is probably going to be extended attribute support. That was a kind of a schlep, just because it was very politically contentious. Linux has this thing called extended attributes. Solaris has this thing called named attributes that are not the same, even though they're called attributes. Named attributes is part of the NFS v4 protocol as it was specified way back in the early 2000s. It did not have support for extended attributes as Linux knows them until recently, and now we support that. And so the user extended attributes in local file systems on a Linux server are visible and can be updated by NFS 4.2 clients. Talk about transports. I think we're one of the few NFS implementations in the industry that can support RDMA transports, and not just InfiniBand, but all of them. Any fabric that Linux supports, we can support with an NFS, with the Linux NFS server. So that's Rocky, InfiniBand. Well, I mean, it's on the slide. We also have 2 software emulation, RDMA emulation drivers in Linux. These aren't part of NFSD per se, but NFSD can use them. One is software emulated iWarp, the SIW driver. Anybody who's got a standard Ethernet card in their NFS server, Linux NFS server, can use software iWarp just to try it out, kick tires. It can also talk to hardware iWarp cards. And the other one is software emulated Rocky. Same deal for all that. You have a standard Ethernet card in your machine, and it will talk to other software emulated Rocky, or it will talk to hardware Rocky. I mean, obviously they're open standard. So, and I, want to mention the file systems that we support, the local file system types. So you may be familiar with Ganesha, which is a user space NFS server. Ganesha is great for file systems like if you want to store your data on S3 or in other file systems where the driver is probably, oh, that's interesting. The driver is not in the kernel already. Lustre, for example, is not in the kernel. I don't believe it's in the kernel anymore. So you would use a user space file, NFS file server like Ganesha for that kind of application. But for any in-kernel file system in Linux, like the ones I mentioned here, XFS, BTRFS, TempFS, ext4, this is the way you want to go. It's very good in terms of performance and stability. I also mentioned NFS re-export here. And what that means is that the NFS server in Linux can act as a caching NFS server that accesses, like say, it can mount a remote NFS server and re-export those files locally. You can even choose to set up an FS cache on the NFS server so that you can store a whole bunch of remote files on that server and access them with local latencies from your local NFS clients. Kind of a spiffy feature. I mentioned some other file system choices you could make here. Fuse is kind of interesting in the sense that it allows the NFS server to access user spaces that are implemented in user space. Not terribly performant, but if you need the capability, sometimes that's good enough. We also support ZFS, if you're not American. ZFS is not an official part of the Linux kernel, but there are ports of it to Linux, and it will work with NFSD. Then I'd like to tout a few additional capabilities. We're kind of proud of the support for Kerberos. It's pretty extensive. I'm going to talk a little bit about a few more details there in a slide or two. NFS v4 referrals, if you're familiar with SMB, that also has a capability where the server can tell a client, oh, I don't have that anymore. That piece of data that you want, that file that you want, go over here and look at this other server. NFS v4 also has a capability, and NFSD in Linux supports it. We do support some forms of pNFS, not all of them. The most complete support we have is for pNFS block, where NFSD in Linux acts as a metadata server, and the data that the clients access is actually stored and accessed via one of the block protocols like NVMe or iSCSI. The NVMe support was added very recently, contributed by Christoph Helvig. For this, I think it's appearing in 6.11, I believe, which was just released yesterday. He wrote the spec for that, the RFC for that, 9561, and he contributed the support for it, and in fact, it was not very many lines of code, and I don't think any lines of code in NFSD had to be changed to support it, so that's kudos to him. We do support some observability. People may be familiar with dprintk. We kind of don't like dprintk anymore because of all the fancy journaling support in Linux now that will squelch any loud chatter from any subsystem. And so dprintk tends to get pretty noisy in the system log, and it will get squelched very quickly. And so that kind of makes the usefulness of dprintk pretty minimal. So we've been, over the years, switching over to use ftrace and tracepoints, the more modern facility. We like those a lot. I won't belabor this point too much, and if you're interested in learning more about it, come talk to me after the talk. Our ACL support, access to control list support, is POSIX only because that's what our local file system support. But NFS v4 doesn't have the ability to expose POSIX ACLs in their native form to NFS clients yet, but I will get to that in a few slides. Anyway, so what NFS v4 clients see is NFS v4 ACLs, which are kind of like Windows ACLs. What's stored on the NFS server for Linux is a POSIX ACL. So that's kind of a lossy translation because POSIX ACLs are not nearly as rich as Windows ACLs are. There's a long story there that I won't belabor. But that's what we support, POSIX ACLs. So, as promised, Kerberos. Kerberos is. Oh, I see a question. Sorry, there's a lot of crosstalk from the other room. Can you say it again?
I know that Linux classic processes in kernel don't do NFS before ACLs.
Yes.
Supposedly ZFS at least has the file format condensed for NFS before ACLs.
Yes, there's. We could repeat the question. Thank you for the reminder. The question is, because ZFS, even though it's not a supported file system in Linux, it does support NFS v4 ACLs. Well, could we support that in NFSD? The answer is we could. Oh, 10 minutes. Really?
No. Not in here.
Oh,
We're good.
okay. Sorry, I'm a little confused because I'm wearing my readers and I didn't see what she's holding up. We could do that. There is no plumbing through the VFS layer in Linux for NFS v4 ACLs. So, it's not as easy as, just start using ZFS and the NFS v4 support will appear. So we'd have to do some work for that. But that's not beyond the pale. We could do that. I think, there certainly is a low hum of interest in true NFS v4 ACL support at all times. I mean, we hear that buzz, that request comes frequently. And, the story is we don't have support in the local file systems, we don't have support in the VFS. And if we had those two things, yeah, we could make that happen.
Anything we can do to support, to revive this, to support Andreas from your perspective?
Well, I just explained it. If we have VFS support, then any local file system like ZFS, yeah, we could do it. Well, I don't have specifics, but you need to do the political work to address support for NFS v4 ACLs in the VFS layer. I don't think that we can do that with the POSIX APIs that exist now. Yes, maybe I should take the liberty I explained earlier and say, please come talk to me after the talk. Or what Bruce always used to say is, patches are welcome.
No, these are not.
Yeah, I'm rather agnostic about whether that support is appropriate or not. So I'm not going to argue with you. I think that would be interesting for a large class of users, and so I wouldn't say no to it. As a co-maintainer of NFSD, I wouldn't say no to it. So over the last couple of years, we decided that it was time to remove support from the kernel, more strongly than just deprecating, but actually remove support from the kernel for the DES-based and 3 DES-based encryption types. So the types that are listed here in the first bullet in the light blue color are all gone in recent versions of the upstream kernel. So you can't pick them even if you have user space support for them. The remaining encryption types from the traditional implementation are the 2 SHA-1 based types from RFC 3962. So those are in there. There is a deprecation schedule for those. Not ours. I think it's from, I want to say, the US government. I think by 2030, those have to be gone as well. So all of that stuff can be built out of the kernel now if distribution chooses. What's coming in its place? I implemented support for Camellia and for the RFC 8009 encryption types. The 8009 encryption types are required to support FIPS 140. So that brings NFS into that world. It wasn't previously because none of the Kerberos encryption types that we had support for were FIPS compliant. So that's a new thing, and I think people will like to see that. I also took the time to add K-unit tests, so we can do basically all the tests that the RFCs provided. It is now coded up and built into the Sun RPC Kerberos implementation, so you can just run those as K-unit tests. I've been talking with David Howells about how we're going to support acceleration on ISA platforms, ISAs that have acceleration for the encryption types that I mentioned so far. What's interesting about the new 8009 types is that they do their AEAD types, which means that the checksum computation and the encryption go together. And so they will see a lot of positive impact from a hardware acceleration. So we're kind of excited about that possibility. We don't have any plan on the ground to implement it, but we've been talking about it, I think, for the last 2 years to see what we can do to maneuver ourselves into a position to support this, because I think I'm a big proponent of encryption on the wire. And speaking of which, I wrote RFC 9289 with my co-author, Trond Mikkelbust. And actually, it was invented here at this conference in 2018 or 19, because we're sort of looking at what Microsoft was doing with SMB at that time. I think they were talking about SMB with TLS and maybe with Quick. And I thought, why can't we do that with NFS? And there was a saner head very close to me at that time, Lars Eggert, who said, well, if you want to do NFS with Quick, you need to start with NFS with TLS, because you're going to have to specify all that stuff anyway for Quick, and why not do it for TLS? Because that's a technology that's here now and you can use. So I said, okay, I'll do that. So there are 2 service levels. One is encryption only. That is, there's no authentication of the peers of the client or server to each other. And the other one is encryption with mutual peer authentication. That is, of course, the much preferred and more secure mode of operation, because, I mean, who cares if you encrypt stuff if you don't know who you're talking to? You could be talking to a very bad actor, even though you're encrypted. It's still, a man-in-the-middle attack is very possible. So you want to use mutual peer authentication, of course. Right now, support exists for X509 certificates on both ends. We would like to do pre-shared keys as well, but I haven't actually gotten to that. But one of the key important things here is the ability for us to use hardware offload, because as everyone knows, encryption has a palpable latency and compute cost. So if we can offload encryption and decryption onto another processor, that means that the host CPU memory cache and processing power is not being wasted on encryption and decryption. It's being done in the network interface card before it even reaches the host. But of course, it also works with software, with the kernel software crypto. So either way works fine. There's been a lot of talk in the Linux community about memory safety. The Rust folks are getting pretty, they're gaining in confidence about bringing Rust into the Linux kernel as a way of re-engineering some of the kernel architecture, APIs and whatnot in a memory-safe language. I think that could be a benefit to Sun RPC, the lower levels of NFS. So I've been working on a number of ways of trying to enable Rust without actually getting my fingers into the Rust pie. One of the first steps has been to replace the old school C macro-based XDR encoders and decoders with the newer XDR stream utilities. But the next step is going to be actually writing a tool that can read an XDR specification, an RFC, and generate code, either C code or Rust code or Go or whatever we want. And I've actually done that. That's where I've been spending my time for the last 2 or 3 months, is building a Python tool that does just that. I'm happy to talk about that for a long time. If you'd like more details, come and see me after the talk. Another thing I've been working on is continuous integration for upstream kernel code. Bruce had this. He basically had a machine in his basement that ran once in a while, or maybe on a nightly basis, a few tests. And my feeling was, that's great, but Bruce, you're retired, A, and B, I would like to see this done in public so that not only do we have public results and we can see the results of the tests, but we can let other people run the test, basically clone them and run them themselves, or they can contribute if the tests are open source, if the test and the test framework are open source. So to that end, we've adopted Louis Chamberlain's KDevOps. It's something that he built while he was at SUSE several years ago. But it's an open source framework for running tests against file systems. It looks like the URL is right there on the slide. So if you're curious about KDevOps and what it is, you can go look at the URL. But essentially, what it is in a nutshell is some Ansible and libvirt, so that it creates guests, or it uses Terraform to set up cloud shapes so that you can get a repeatable environment in which to run tests. It's under heavy evolution right now, because there are a lot of people who are starting to notice that it's something that's useful. I believe BTRFS and XFS are both file systems that are starting to use it. We've spent the last year or so building NFS-specific workflows for it. So before it was just XFS tests, and now we've got pNFS, which is a Python-based synthetic client that can drive server unit testing. The Linux test project, an NFS tests tool, which comes from Jorge Mora at NetApp, and a workflow that runs the Git regression tests on NFS. So it's been a hefty amount of work that we put into this, and I now run this nightly, and so do several others. So we've got a lot of testing going on, a lot more than we used to. But this is in no way complete. We know we've got testing gaps, things like Kerberos and TLS and pNFS, and there is some RDMA testing in there using the aforementioned software iWarp emulation. But you know, obviously CI is something that's very resource intensive, and you know, we need a lot more CPUs. Did I skip a slide? No. I thought I'd also mention that I'm regularly testing the long-term stable kernels. Those are, right now, long-term stable kernels are 5.15, 5.10, 5.4, 6.1, 6.6, and 4.19. These are maintained by the community long, like 5 or 6 years after their first release by Linus. And the reason, we didn't used to do that for this kind of, we didn't pay this kind of attention to the LTS kernels in the NFS community, but I've started to because it's pretty apparent that Linux distributions like to use the LTS kernels. My company uses 5.15 and 5.4. I believe Ubuntu is on 5.10, and that's used in Amazon's cloud. So we really need to have NFSD, a good level of confidence that NFSD is working well in those LTS kernels. And so I run all of the CI tests, the workflows that I just mentioned, in nightly on the LTS kernels to make sure that they're in reasonable shape. So what's been happening very recently in terms of new features? Interesting. Good. I'm glad that you asked that. Some of you may know that NFSD has supported read delegation, NFS v4 read delegation for quite some time, probably since it supported NFS v4, so that would be almost 20 years. But it never supported write delegation. Write delegation is basically a promise by the server to tell the client if there are any other clients who want access to a file, and in which case the client is then, the client that holds the write delegation is free to handle application open requests locally. It doesn't have to go over the wire. That's a pretty hefty performance improvement. It also enables the clients to handle locking requests, lock range requests, because it has a delegation. It knows there are no other clients that it has to pester the server and ask about. So we added support for the CB getAttr callback. That allows the client or the server to ask clients that hold delegations, oh, by the way, has the size of this file changed locally for you? If so, I can hand that size to other clients that might be asking about it without recalling your delegation. So that's kind of a performance enhancement. The bullet point that starts "note that" is kind of important, and some people don't really realize this about write delegation. But there's a POSIX rule about M-time, which requires an M-time. If an application does a stat, the M-time in the stat has to reflect the most recent write to the file, which means that if you've got 2 applications running on a client, one of which is writing to a file, and the other one comes along and stats that file, if the client is still caching those writes, they haven't been sent to the server, for example, that means the server's M-time is out of date. And so the client is forced to flush all those writes back to the server and then do the getAttr to get the M-time. That's an enormous performance overhead. People don't expect it when, the classic problem report is, I've got these applications that are writing to files and I did an ls-l in that directory and it took forever. Well, this is why. So, before the client can do a getAttr on that file, it has to flush the writes back. We're hoping that there's enough new mechanism in NFS v4 and extensions that are coming soon that we can forego the the issue of having to flush dirty data back to the server to get an updated M time. I will get to that in a couple of slides because that's interesting work. We're also working on directory delegation. That's basically a read delegation for directories. So a client can go, I need to create 10 files, and it can ask the server, is there anybody else looking at this directory? And the server can say no, and so that the client doesn't have to synchronously push all of those directory entry creation operations into the server, so it can accelerate and go a little faster. And also, there's a change notification mechanism built into this. This is already implemented in FreeBSD, and we hope we've been working with the FreeBSD author to implement something that's going to interoperate with them. This is specified in NFS v4.1, so it's not something new and crazy. Go ahead.
There's also a question about the M time that you mentioned. So, assuming that the client holds the delegation and it updates the file, of course the M time gets updated. Should it notify the server about the M time update in case another client does?
He's asking about when does the client have to update an M time. The server's local file system is the one that controls M time. That's why the client has to push all those writes back to the server, and then the server can report the M time, because those writes have to hit the M time, have to hit the server's local file system. Does that address your question?
Yeah, so until the client sends the writes the data back to the server, the M time
Right. That's why it has to flush those. But hold that thought. Not a lot of people, sort of a change of topic here, not a lot of people know about pNFS and the support for parallel NFS block layout in NFSD, but it's got it. It's had it for 10 years. We're recognizing the stunning and callous lack of documentation around this, and also adding it to the CI workflows that I mentioned before, because I think this is probably a very interesting performance play, because the clients can basically do I/O directly to a SCSI LUN using pNFS block. NFSD has a simple implementation, that is, it doesn't do RAID or striping or anything like that, which is in the specification, but we didn't implement because it's a little more tricky. I think we were initially interested in just being able to put a file system on a SCSI LUN and having clients access it directly via iSCSI operations, and that works pretty well. I've been testing it. We're about to write some documentation to explain to people how to set it up, because it's a little tricky. And as I mentioned before, you can do this with NVMe now as well. We think that's a pretty important feature. Another thing that we did over the last year and a half or so, 18 months or so, is something called courteous lease extension. Basically, when a network partition occurs between a client and a server, the server gives the client up to 90 seconds to contact it to keep its leases active of the open and locked file state. And if the server doesn't hear from the client, it will purge them. It will just toss them out, and it will assume that the client has crashed. Well, network partition doesn't mean the client's crashed. It just means that it can't talk to the server. So throwing out open and locked state is a bit draconian, and is actually pretty disastrous in some cases. So what we do now is, instead of tossing at that point, we put the lease information that the server holds into this intermediate state, where it stays there almost indefinitely unless another client comes in and wants to open one of the files, and then it's thrown out. So there's a chance, there isn't a lot of sharing between clients in NFS. It can happen, but a lot of use cases are covered by just leaving that state alone on the server until the client is able to reconnect. So we think this is a pretty interesting feature. My co-maintainer, Jeff, has been working on something called multi-grain timestamps. One of the problems that we have is local file systems on Linux don't always store fully fine-grained timestamps in their A time, M time, and C time. That's a problem because changes to a file, several changes to a file can happen close enough together that the timestamp granularity doesn't show that the file is actually changed more than once. That can lead to some races where a client doesn't invalidate its cache, and so it has a stale version of the data in the file, and bad things happen. So the reason why, of course, file systems don't update timestamps with that kind of granularity is that it's expensive. It's a right to durable storage for every timestamp update, or at least to your journal. So the compromise has been to update the timestamps only in the cases where we're sure that somebody else is actually looking at the timestamp. That sounds crazy, but it actually works. There are some details that he's still chasing down. You've got to maintain a floor timestamp for the file system to make sure that when you're doing a make, the source and the object file timestamps don't go out of order, because that can be possible if you're on a big system with lots of CPUs and lots of different time sources. Anyway, we think this is an exciting feature because it's going to make the caching that's done by NFS clients more resilient. And that's about all I can say about that, because he's done the work and I didn't, and it's pretty impressive work, but I don't understand it. Oh, yeah, there. So it's explained on the slide. Oh, and as the bottom bullet point says, one of the requests that when we did this work, especially by Dave Chinner, the lead, the former maintainer of XFS, was we don't want to have to change any code in the file systems to do this. And so Jeff did it all in the VFS. So all file systems that can, will get support for this. So what do we think is coming in the next year to 18 months? A lot of new administrative features. Jeff has been building a netlink-based administrative interface for NFSD. The old one is in the proc file system and is way outdated. It's like 30 years old. And we have lots of new things we want to add to the kernel, of course, and changing proc is a nightmare, mostly politics. Let's see, what else in here? Oh, we're working on a dynamic thread pool sizing feature where the thread pool can grow and shrink depending on the workload on the server. Naturally, that's a lot more complicated than it sounds, but some of those patches went in 6.11. Some are going to come in 6.12. Our support for NFS v4 referrals is just a little lacking around the edges. One of the problems is IPv6 addresses, and how we're going to support that we don't like the idea of having to support that in Etsy exports, which is how referrals are set up now. So we're going to move to an NFS ref command line tool. This is exactly what Solaris does, and you basically give the tool an NFS URL and say, point clients at this URL, which can specify an IP address or a domain name and a port and a path name on that server. I mentioned copy offload before. I found some problems in it that sort of made me a little sick to my stomach. They're security-related problems, so I had to turn it off in upstream. But I'm working feverishly with the person who authored this code to rectify these problems. I mentioned some of them here. I don't have to go into a lot of detail unless people are really curious. But the the upshot is that asynchronous copy was done only with a CB offload callback. And I've talked to folks in the SCSI world, and they're like, you can't do it that way. Basically, that's not reliable enough to support offloaded copies. You have to have a way of polling for completion. And NFS has one. It's called offload status, but the Linux NFS client doesn't support it yet. So I've written it, and we're working on getting that into the Linux kernel. There's a new draft standard called delstd that allows you to do the same kind of delegation tricks that you do with data, read and write, and directories with some attributes. So the thing that we were talking about before about mtimes, basically it says, okay, for the time being, Mr. Client, you can manage the mtime all you want, and you can update it as often as you need to. And when you hand the delegation back, you have to have a write delegation to do this. When you hand the write delegation back, tell me what the mtime ended up being, and I will put that in the file. So in that way, that obviates the need for having to push all those writes back to the server in order to get an mtime, an up-to-date mtime. Basically, the client can do it itself. There's another feature in here. It's today when the server hands out a delegation, it returns an open state ID and a delegation state ID. And with this extension, you have a question? Can you speak up, please? Are we trusting the client's clock to set that mtime? Yes, we are. Yes, no. It's the whole, you get the whole mtime. The client gets the whole mtime. Yes. As I was mentioning, today when an open returns a delegation, you get back an open state ID and a delegation state ID. And this draft allows the server to return one or the other, because generally what happens is if it returns a delegation state ID, a read or write delegation, the client's going to go, well, I don't need to keep the open state ID around. Here it is back. So let's just get rid of that little piece of work and just, the server says, okay, I'm returning an open state ID, no delegation, or I'm returning a read or write delegation, not both. So a lot of that's coming to 6.12. I just got a problem report with one of these things that I need to revert some of this, so it's going to be a little more delayed for some of it, but the client already supports this stuff. So I mentioned there's going to be more yummy stuff about support for access control lists. And here it is. Basically, for as long as NFS v4 has been around, we've had NFS v4 ACLs, which are richer than POSIX ACLs, but not compatible. So now it's been proposed, hey, what if we add support for POSIX ACLs in NFS v4 as well? So we'll have the ability for clients to ask about, what do you have on this file, Mr. Server? Do you have an NFS v4 ACL or a POSIX ACL? And the server gets to say, oh, the file system supports only POSIX, so here's your POSIX ACL, or the file system supports NFS v4 ACLs, so here's your NFS v4 ACL. Go ahead. In the Linux world, he wanted me to comment on the demand for support for POSIX ACLs. It's more than a low hum. It's people ask for it all the time. It's a real pain in the butt because, as I mentioned, the translation between NFS v4 ACLs and POSIX is lossy. And so a client might set an ACL. It will have to be translated into NFS v4, an NFS v4 ACL, sent to a server. The server then stores that translation of that into the file system, because the file system only supports POSIX ACLs. And then it has to come all the way back and through 2 translations. Can I name the file systems?
I'm curious because I've been focused on Apple for a long time, and it seems like everyone is moving to the NFS Windows. Linux is not, right? Linux is not. So basically, anything on it.
So here's the question is which file systems in Linux are asking for support for POSIX-ACLs? All of them. We don't have any file systems native to Linux that support NFS v4 ACLs, and so they all want POSIX-ACL support in them.
This might be good discussion on tomorrow in this fall.
Yeah.
Okay.
The birds of a feather tomorrow night would be a good point to talk about that.
All right. Yes, there is an NFS birds of a feather tomorrow night. How many minutes do I have left?
Not any, but you have a 15-minute break.
All right.
You can take a
I think I'm.
listen,
Yeah.
couple of questions and keep going.
Let me. Sure. I only have like 2 slides left anyway. So there's this new concept that's come up recently called local I/O. Basically, if the client server determined that, oh, they're both running on the same physical host, like they're in separate containers, but they're both on the same physical host, then the client can use, I don't want to say direct I/O because everybody knows what direct I/O is, and this is not direct I/O, but the client does I/O internally in the kernel on the physical machine so that the read and write happens without going through NFS. This is work that's been contributed by Hammerspace. They've been doing something like this, prototyping it and actually, I guess, running it at customer sites for the last 10 years. So there were some issues to work out in terms of security, but now I think it's going to come either in 6.12 or 6.13. It's imminent. If you want more information about it, I believe the author or the person who's responsible for getting this upstream is going to be giving a talk tomorrow afternoon, the pNFS Hammerspace talk. And then the talk wouldn't be complete if I weren't going to say we're going to rip it and replace some stuff. NFS v2 is probably something that's not used anywhere anymore. We're pretty sure it's just it's not something we need to support, and it would help our test matrix if we could get rid of that. So we're thinking about that. I mentioned at the beginning of the slides that we still support UDP. Indeed, we do. But that's another thing that would help our test matrix is if we didn't have to support that, we could take that out of the kernel. I mentioned the AES-1 encryption types. Those do have a deprecation schedule mandated by the US government. And some people have pined for a day when they don't have to ever deal with NFS version 4 minor version 0 ever again, because it's got lots of holes and everybody's using v4.1 now to great effect. So there's some talk about removing it. I don't know how serious that talk is, but well, I just want to thank my hosts and the folks I work with, because as I said, this is a very feature-rich piece of software, and it wouldn't be nearly as good as it is without the support I get from my contributors and reviewers and co-maintainer. Thank you. Any questions? Go ahead.
Anything additional coming in the identity-based authentication space outside of kernels?
The question is there anything coming in the identity-based authentication space outside of Kerberos? There's some talk. We're looking at OAuth too. But yeah, I mean, if you'd like to steer the standards process a little bit, if Microsoft would have, any suggestions for us that would help your cloud work or whatever, then I encourage you to get involved because it's in the early stages. People are just sort of, we haven't even written anything yet. Well, Tigran has written something, but it's an incomplete problem statement, and he would like a lot of eyeballs on it so we can start steering that. The short answer is not much. Any other questions? Go ahead.
It's a lot more future-looking. Tracking the progress of Rust in the Linux kernel is a great joy. Are there anything, like there hasn't been any real movement for Rust doing file system work yet, let alone this thing. In terms of being able to upstream it, is there something that you think would be a good fit for something other than C in the Linux kernel in the NFS server space?
What languages do you think will be better than C for?
Rust in particular, because it's the only other language that has supported the kernel.
So here, I don't agree with the presupposition that Rust has been solely rejected in the Linux file system community. Actually, there was a presentation at this year's LSF by the guy who's actually writing the new APIs.
I don't mean to suggest it's been rejected, just that I haven't seen it actually get upstream yet.
It's complicated.
I get that.
The paradigms that are available in Rust are very different, and the approach that the fellow took was to basically reconstruct all of the APIs. The problem is he's not a file system guy. And so he didn't really understand why the APIs work the way they do, and he correctly observed that there isn't a lot of really good documentation for the current APIs in C. So what he constructed was something that raised the hackles of the more seasoned developers, and maybe he mistook that as another rejection, and so he's sort of gone off and started doing other things, which is too bad. There are others who are carrying on the work. I think, I'm very interested in seeing what Rust can bring to things like NFS, the remote file systems. And NFS is not the only one in the Linux kernel, by far. The other choices are things like Go or something else. I haven't heard much there. Rust seems to be the loudest contender. But I think work is ongoing, and we're going to see some progress there in the next year to 2 years. I probably need to get off the stage now. Thank you for coming.